Welcome back to Made of Wires, a late show today, and a short show. We've been decompiling Castlevania Symphony of the Night, and we're going to keep working on that today. Don't have any updates on my attempt at getting a save point for the Ralph Grant Sifa, there we go, boss fight. But that doesn't mean we can't decompile it. So we're going to be working on the same function that we were yesterday, trying to finish it off, and if we get it, then we'll move on to something new. And if we don't, then we don't, and that's a bummer. But that's okay. You can go to sutton.z.dev to learn more, and like, subscribe, do all the things. I noticed that since moving to doing lives directly on YouTube, I don't get new subscribers anymore, so if you haven't subscribed and you are watching, please do. I think the way that uploads are suggested to people is different than the way lives are suggested to people, and the VODs don't get recycled, or so it seems. So if you subscribe, you get them in your feed, and if you don't, then nobody sees them. I'm going to work on figuring that out, but let's get into it. So we're using decomp.me, as always, and as usual, we have to coerce decomp.me into rendering correctly. This is a Safari issue, not a decomp.me issue, but I feel like I usually have some incantation that will get it to render properly, and then I don't remember what that is. We'll see if this one works. Well, this one didn't work either. Sometimes I feel like getting some purchase up here. And there we go. Maybe. I don't know. Let's try to get to the save. There we go. All right. So what we're missing is at least one variable. So we need to figure out what variable is missing. There's a something here where I'm kind of forcing some data storage. That seems obviously wrong, and so we're going to deal with that as well. And so let's just get to it. We're going to start at the top, move down, and try to resolve things as they go. So what I want to see, basically, as I'm going through, when registers are being used, are they being used consistently? And if they aren't being used consistently, is there anything we can do about that? And so the first thing we have here is prim index, and we already have prim index noted as register S8. There's nothing more to do there, except I like to scan through and just see if this is being used again, and if it's being used the same way. And so I highlight, even though it's S7 in ours currently and S8 in the other, I like to make sure that they are being used the same way, and in this case they are. Next one I see is S1 and S2, and kind of the same thing here. Try to figure out, that looks like prim. Try to figure out which, sorry, maybe prim buff? No, it's like prim. No, here it's being used for the temporary storage for calculating this prim buff offset. But then it's being used for I down here, and that's fine. And again, just go through, make sure it's being used the same way everywhere, and that gives us a pretty good assurance that those two, that variable, the way it's being used is the same throughout. S0 is the next one, and we've got S0 for our prim pointer as well. And that seems to be used consistently. One thing I noticed here is a slight difference. I think that's just because of the 4 bytes of different. Yeah, it's the end in both cases, so. Brief aside. All right, so we were looking at S0. Now we want the next S register that we see. So we want to load into something with an S, and we're not seeing anything. A0 actually is not a bad choice either. A0 is the argument register, but it can be used for a variable or anything else as well. But that looks like it's mostly being the same. It's not as consistent as the S registers, which are used typically for variables. All of this is very consistent in this midsection. Uh-oh, roaming's online. There's a new decomp.me feature. What is it? What is it? No, I did not see it. So here I think this is probably where we're going to run into the majority of issues. Top right corner, collapse matching ASM. Oh, look at that. That's interesting. I like it. And the first thing I see is that, thank you, roaming. Thank you for pointing that out. So SP vector, let's get back up here, is S1, and rotation matrix is S5. They're inverted here. There are some cases where S1 is being used when S5 should be used. So let's go down here and look. And we have S6 as well. So 158 is the first issue. 158, it looks like, should be S6, which we don't have. So we need a new variable here. And I'm uncreative, so we'll call it SP vector 2. And this may be the missing variable. So 159 now. Let's look for any of these rotation vectors. Back to that line, and so we're looking so this is getting set, but then S5 is being used, and again S5 was the transportation, or sorry, S2 is being used, which is our rotation vector. So it looks like this is being set and then not used. And it looks like I screwed something up. Hey, Wompty Dumpty Dom Center, good to have you. So let me try this one more time. So we have our dummy matrix that's going into just some stack pointer. We're not going to worry about that. And then we have this assignment to S6, which is now our S8. And that is used eventually down on 191. So let's grab that vector, go to 191. We'll use it there. And did that undo my... It undid me. Let's get this again. We want S6. And right now that's our S7. 192. I don't know if I like it. I've always had some issues with... Oh, that actually looks like it cleared up a lot of things, but we'll keep going. with collapsing things. Like, I don't know, my brain doesn't work that way. It does seem useful though. So S1 and S2 look the same. So this may just be an ordering issue, because they're used the same always. Okay, so let's look at what S1 and S2 are. They're very different. I'm going to throw I way down here. Sometimes it matters, sometimes it doesn't. Let's move... actually, let's get rid of the array for SP dummy matrix. I do think we have a variable here that isn't used. Okay, so it is possible that these registers... actually, a lot of this may just be out of order. So let's move the rotation vector up. Which way would I... Actually, let's do them top to bottom. It's not working. Let's get to the save there. And let's try it on the PlayStation. See if the PlayStation likes it. PlayStation doesn't completely like it. So there still is something going on. All right, back to registers. I will collapse it and see, are we just failing at this bottom section? And it looks like that is almost the case. 31. We're getting S2 instead of S1. They're always used correctly, though. I'm not worried about the immediates. We don't have any use of S2 until we get down here at 132. And that seems to be the issue. We need S2. And S2 is SP rotation vector. So there's a bunch of cases here where we're doing the wrong thing. And that makes more sense. So we're gonna change this to the rotation vector. And I think this is going to be VY. And that's going to collapse a bunch. Just want to make sure that that's the right thing. Better. So now I think RS2 is the correct S2. S5 and S3. Okay, we have one difference on 172. Which should be SP vector again. And that was it. And our SP dummy 158. Let's spread that again. Correctly gets assigned to the stack instead. Yesterday we talked, and now I have my bar again. I have no idea why, but I have it again, which is nice. And does this work? Not quite still. So there's still something. There's something a little off. So, some change to be made that will affect compilation on GCC, but not on the PSP. So it's possible that it's ordering here. So we can kind of try to force ordering. Oh, it's probably this, the Bar S3 edition, or one of these may be up in the next section of the for loop. Let's look at that on the PSP and see if that's something's happening there. So it isn't. We have our add here. If we move it up, that's going to be out of order. If we put the prim next up there as well, that might cause some issues too. Let's try moving. We can't move it after. We can try putting all of this up here. Really like that, but if it does the right thing for GCC, so that compiles fine here. Yeah, it still doesn't work on GCC. Let's undo that. I might have to just moving this down, change anything? No. What else could be going on here? This is out of order. And if we look at what the original was doing, we need to find that default case here. M2C can't figure out a bunch. Why is it so bad? Oh. I have a... M2C can't handle if defs, which is why we can't have them in the context normally. That's unfortunate. That's a pretty easy thing to do. So one of the things that I did, and M2C must be able to parse this. I did this for Soten Lint. There's a C-Lang crate. I think M2C is written in Rust. There's a C-Lang crate that makes it makes all this trivial. Rowing says, and maybe this is a bug fix. Very interesting, Rowing. So I didn't have that. I didn't have that originally. No, I do need that. Okay, so let's look at this a little bit more. So here's our our next statement. The signed less than is happening here. And the order that happens, when is it being calculated? All it has to do is be done after when I is incremented. I is not used anywhere in here. Or is it? I wouldn't think that it would be. So as long as I being incremented happens first, which is way up here out of order, that's fine. What does this add? That's part of this. So it kind of mixed all these things together. So I was looking, we talked yesterday about why would this be in the scratch pad versus in memory or wherever. And I did look at that a little bit. So Scratchpad has a 1 clock cycle read penalty, whereas registers, you can use them immediately. Main memory is 5 to 6 clock cycles. And so what GCC will attempt to do when it has to go out to memory to read like these fields in the pointer, it will actually, this could be rearranged a bunch of different ways, and I might try to do it that way. It will try to put as much stuff in before the reads as necessary. Hey, no problem. Thanks for showing up, morning you. And so what we want, I'm gonna fix this context so I can get a M2C decomp again. We want this one. All right, so what? So this has Z priority plus the division minus the scratch pad. So let's try that. Anyway, I don't remember what I was saying. Oh, this this was a terrible grouping anyway. I negated the Z priority, which shouldn't be. That looked like that might be. No, still not it. Let's try doing the subtraction next. Even worse. Let's move the division plus the Z priority minus the other thing. No good either. This one seems to be the best, but still not exactly what we want. And we can, again, try to force the ordering. And that did it. So I'm hoping that that works still here, and it does, which is good. So the order, we need to determine what the value of each of these elements of the expression are, regardless. And what order that happens in is not super important. The ordering importance here is left to right if there's no side effects. If there's no side effects, we should take this Z priority. And yeah. And so, however this is done, let's go back and look at the order before. I'm a little surprised actually that this ended up working. And why would GC? So the ordering of these expressions is defined in C, and I suppose if you're... So why would... I'm sure the instructions work out to the same order either way, but we should do this subtraction first and then do the addition. And by forcing the group like this, the subtraction does have to come before doing this addition, and the order that the registers are used, left or right, or first argument or second argument for the addition doesn't really matter. So I guess this is fine, and it works on the PlayStation. What if we took this and moved it to the end? Does that make a difference? Yeah, that does make a difference. So we'll keep it the way it is. Some compilers just have sensitivities that others don't. Yeah, I mean, the addition should be the same regardless. How the compiler orders some of the other parts of the operation are less important. So it has to load this memory eventually. What order it loads the memory is not terribly important. What order it loads this memory is not terribly important. In comparison to those two loads, loading this, doing the addition, doing the division, not terribly important. What is more important is the result of this expression subtracted here first, or is this addition done first? And the C language has rules for that. And I believe it's left to right. Where the result of each of those expressions gets put into registers, like for the add instruction, like these add unsigned instructions, where is it V1 or V0? Which arg is which? Doesn't matter. At least as far as I know, with the semantics of that instruction, it doesn't matter. So I'm not sure. To me, both of those should have read the same way. The precedence for the division is higher than the addition or subtraction, so it should have been done first regardless. And then since this was the leftmost term, the subtraction should have happened next, and then the addition. And so we're just forcing that. How the compiler, like I said, how the compiler arranges the original or final bits and the instructions, that's up to it, as long as those general rules are maintained. All right, so let's get this into place. I don't remember what function this is anymore. I think, like I said, I think this is the caskets spinning. And on the PlayStation, this is in its own file. It's a little unique. Hey, Dizik. So I liked, Morning, you mentioned the practicality of decompilation and the relationship between source and assembly. I do think those are important. But not knowing them, I think, limits how you might make different decisions, or how you might debug even. And even if you're working in a higher level language, like I did many years of server-side Java, and you would think, well, you have a debugger and all this other stuff. There were still times where I wanted to look at class file instances and see how particular. It was rare. There were other times where, especially C, early on in my career, I was working on a PHP application of all things that was hanging at certain spots. And we couldn't figure out why it was hanging in there. There weren't tools really to inspect where the PHP application was during hanging. And so you attach GDB and you look at what the thread state is for the hung thread. And along with that, you may get a source listing if you have debug symbols, or you might get just assembly. And if you have just assembly, what are you going to do? Are you going to just give up? No, you gotta figure out something. And in that particular case, it was hung on a syscall. What was the syscall? Go back up and see what the number is. And it was hanging on reading dev random, because on Linux at the time, dev random was blocking, and you had to use dev random if you wanted a non-blocking random, even though every Unix by that point had a non-blocking dev random except for Linux. I know Linux isn't Unix, but whatever. I moved this out into its own header, so we have to include Scratchpad. We need an extern. Fortunately, and I'm biased, but I find that MIPS is really easy. It's very straightforward, very few functions. We're not going to be able to get the PSP version in right now, but I do want to see where it is and make sure that it's split appropriately. And what I want to see is this should be in its own file, and it's not. It is at the end of this file though, so it should be pretty easy to split off. So we need unknown A98. We do have data, but yeah, some of it will be related to this. I'm going to go over back to the decomp. The decomp will tell us that I have a broken context here as well. The decomp will give us what globals we need. Yeah, that works. And so I'm going to see in the data section where that is, and then we'll update some things to match the C version. So we need to see where this is, or what the offset is. It's 22A8. Let's get back there. And I'm going to name this the same thing as the PlayStation split to make it easier to integrate these later. I did a few things to make this a little easier as well. I have a rbo.h in the PSP directory now, which just includes the PlayStation's rbo.h, and that allows me to keep the source files the same. I don't have a different header now that I'm including, or a different path to the header. So we're going to move this over, and we need to update this name. And now I want to look at the data as well and make sure that gets moved over. And so our first array is here at 0302. And so we'll look for the A98 data, and we're just going to split it at that offset. And use that same name. And we should be able to, this should work fine. As usual, something breaks. It looks like I may have screwed up the name. Can I not save this first? So we're not getting... It's like we're not getting... That was generated. What did I just look at? How is this different? This is exciting, I know. Don't like to see the difference, but that's not the way my brain works. Oh, I missed the... I've been doing this. It's a problem. I've been missing the RBOO. It always takes me a while to see it, but that's what it is. So we can go back over and deal with the difference in data. What I think I'm going to do instead, most of these are probably going to end up being static. So we have this array, another 16-bit array, and a bunch of 16-bit values. How much? I don't know how much of this is actually related. Let's close all these things. So we don't need GPad pressed anymore. We have 4 variables that look like they're related. What's this? This one, which looks like it's missing, or... No, it's not part of this. Okay, that one's Don't have to worry about. So we have three variables. This one is a bunch of pointers. Okay, yeah, I remember that. And then that S vector. This one. There we go. This one here. And so everything after, I think, is not actually part of this. Yeah, so 1BA8. This is something different. So let's split that off into its own thing. That looks old. Nope, 19BC. Okay, so the first part of this 19BC is going to be part of this Func US. And then at 1BA8, it no longer is part of it. And what we're going to try to do is get all that data into our C file and replace these externs. So the byte array is pretty easy. I'm going to put some commas at the end of this. Get rid of everything in the front. That's not what I wanted. Yeah, that's that. These are going to be a little trickier. So these are, they're each going to be short, sin16 short arrays. And I'm going to use a regular expression because that's what you do when you want two problems. So we're going to look for a G label and then some match. We're going to look for not new lines. And then a new line. Then we're going to look for everything we can until we get to .word. Another match. And again, a not new line. And then a new line. Then we're going to do that again. Then we're going to look for a new line and a dot size to the end. And we're going to, now what we will do is make that static sin16 our identifier. Ooh, no, I need to be smarter about this. I need to actually break this up, otherwise it's going to be painful. So we want the hex identifier outside, and then we want to grab 4 hex values, 1, 2, 3, 4. And then do it again, 1, 2, 3, 4. And then the same thing down here. Let me get rid of this and see if this will match again. Oh, screen, yes, thank you, thank you. There we go. 1, 2, 3, 4. And then we do it again. And now we want to look for dot size to the end. This will be static sin16 array. And we want our name is going to be first match. We're going to have the third match, the second match, fourth match, and I think the last one's always going to be 0. But the third match, and all those need to be prefixed as well. Oh, I screwed it up. Oh, what did I do? I screwed it up, that's what. I just searched and I didn't do a replacement. Oh, there's my timer. We'll get this and then we'll go. The /G probably isn't necessary. That means do it multiple times on one line. 30 substitutions. How'd we do? It's pretty good. But it's wrong. I was off by 1. Should be 5 and 4. That's better. Now this one is an array, and this is going to be a static sin16 pointer array. And will be quite a bit easier than the last one. Basically, this is the same as the bytes. Oh, why did it go backwards? Too far. All right, so now we got that done. Now our data is a dot data instead. We want to get it from the C file instead of getting from the assembly. And make rocket go now. Worked. Great. Oh, these were S vectors. So any static sin16, I'm going to change to a static S vector. Drat. We need a not space star. And we're going to change that to a static S vector 1. Why was nothing done? Static S16. Not that. Excuse me while I suck at declaring things. This one's easier. Status. It's static. That. Initializer element is not constant. It looks constant. these all need to be references. Because now they're not arrays. A pointer, or the label for an array is a pointer to the array. But that's not true of structs. So we need to make all of these references to the struct. So even though the memory layout's the same, the way that they're treated is not. So we have a few conflicting definitions. Yeah, so this needs to be an S vector pointer array, which is what we had before. For this as well. And that gets rid of all the warnings. Now, and the reason I did this is because it allows us to go back to the PSP config and we don't have the symbol name yet. Rat. I'm gonna hack. Let's hack. I hack out of love. So our name is this, but we don't have that yet. So I'm going to do something quick and dirty just to get it done. We're going to define our PSP function name. No, because we need the symbol. Can't do that. Yeah, I can't do that. Shoot. Okay, what we can do instead, not quite as good, but nearly as good. I was hoping to just copy the whole C, or copy the whole, not copy, reuse the whole thing, but I can't do that yet until I map the symbol. Grab this symbol name, put it somewhere safe. I'm gonna go back over and so now we have this. We have some data somewhere that's mapped to funkus. Change that to .data, and this should work here too. I screwed up the header file along the way. I think that's what's caused. No, I didn't. What is causing these issues? Oh, looks like a type error. I see. Got it. Now what? Does this not know what an S vector is? Yes, I knew this was going to be an issue eventually. So we're going to cast this. We could do load word. But I'm going to cast it for now. Still no? Odd. Something with types. This part makes less sense to me, so I'm going to call it a day. We'll, oh, God. This might be why. Let's see. This is correctly incorrect. Let's see where it goes. Case 1. So some cleanup still to do here. We'll get this one corrected. And there we go. So that works. So some variable mapping and function name mapping, and then those will be the same. There's only 2 lines, I think, that are different. Maybe with the cast one more, but we're getting there. We're getting there. So, as always, time to sign off. We've been decompiling Castlevania Symphony of the Night. Don't name that variable Stinky Pants. I'll name that variable whatever I want. Good to see you, Aldrich. Sorry I didn't see you earlier. Go to soten.z.dev and learn more. I've been gone away from Discord so long. People probably don't know I exist anymore, but I am still here. Adios.